Okay, here the recording in progress. So start sharing the screen. All right, so now that Thanksgiving is over, we're almost done. I mean, it was a long time ago. Last Wednesday, I gave you the quiz. You should have gotten an email back from me about your quiz. And I also sent you the video on the solutions. I think that was literally on Thanksgiving Day, but be that as it may. So if you didn't get your quiz score back, let me know ASAP right away. Okay, so we just have left the ellipse, the hyperbola, and something called parametric equations. So we should finish in plenty of time. Okay, we are looking for the last exam to be Thursday the 9th that I've decided. Again, it doesn't mean that I'll finish grading your exams by the next day. I'm not even sure I can get it back to you by that weekend. But again, that shouldn't matter. I will at least have the solutions video. So you can just study off the solutions video for the final exam. Okay, so that means Friday the 10th of December, that's our last regular day. It will just be a glorified office hour, I suppose. You can ask me questions or not. You don't have to join if you don't want to. Then we have the final exam. You say, how do I study for the final exam? Just review the previous exam. So just look back. I guess the best way is to look back at the video. Okay, so the videos were generally on the following day, right? So look for what? Saturday 9/4, Saturday 9/18, Friday, so Saturday 10/9, and so on, for all the previous videos. And just use that to study for the final exam. You're allowed 6 cheat sheets. The easiest thing to do is just take the previous cheat sheets and just bring them all in. No need to reinvent the wheel. You already had it, so just bring them all in. If you say to yourself, oh, I forgot to put some formula in, I wish I had put it in, you can put it in for the final exam. You can go ahead and modify that. Okay, so the first day of final exams is our final. Okay, 8:10 to 10:40. So use the same Zoom link. I'll let you use the exact same Zoom link as before, but please notice that it's 8:10 to 10:40. Okay, and just to let you know, because I'm supposed to, I'm legally obligated to say it, I do have office hours Tuesday, Wednesday, Thursday during finals week. If you're interested, email me or let me know. It won't be the same Zoom link as we've been doing. Okay, but you know, in our case, the final would have already been over, so there's not much to talk about. You can always email me for stuff, as the case may be. Okay, so we're getting near the end, and I'll get going with the ellipse now. Okay, all right, and before doing the ellipse, I do have some more parabolas to show you from way back on the parabola section. So let me get you back those, in particular pertaining to problem 31, I think it was. So back in the parabola, page 326, 31, find the equation of the parabola with axis parallel to the y-axis, and vertex passes through the point P. Okay. So 31A, axis parallel to the x-axis, to the y-axis means it's going up and down. That means x is squared and not y. Vertex is the origin. I know it's x squared equals 4py. How do I find the p? Plug in 4 for x, 6 for y. So 4 goes here, 6 goes here. It's one more time. The axis, it said, was parallel to the y-axis. Problem 31 there. Axis parallel to the y-axis. I mean, it's going to go either up or down. Now that it goes through 4, 6, I know it opens up. 16 equals 4 times 6 is 24. Divided by 24, p is 2/3. Put 2/3 back in here. So x squared equals 4py, or x squared equals 8/3 y. Okay, then for C, they tell me the vertex is 1, 2. And the parabola passes through 5, 8. So very crudely, here's 1, 2, here's 5, 8. Again, it's going to open up. So x minus 1 squared equals 4py minus 2. This got translated off the origin to 1, 2. Now I plug in 5, 8. 5 goes here, 8 goes here. 5 minus 1 squared equals 4p, 8 minus 2. 4 squared is 16, 4p, 6. 16 equals 24p, so p is 2/3. Okay, take that 2/3 and plug it back into here. That gives me 8/3. So the final answer is x minus 1 squared equals 8/3 times y minus 2. And then some other ones again, these might be repeats. 23, focus is negative 2, 2. Directrix y equals negative 2. Okay, focus is negative 2, 2. Directrix is down here. Halfway between them is the vertex, negative 2, 0. Focus directrix, so it opens up. So the vertex were at the origin, it would be x squared equals 4py. But this got translated to negative 2, 0. So x gets replaced by x plus 2. X plus 2 squared equals 4py. I now know the p is 2. So x plus 2 squared equals 8y. Okay, and finally 25. Vertex is negative 2, 2. Directrix is x equals 2. X equals 2 is here. Vertex negative 2, 2. Okay, so that means my p is 4. I go the other way for the focus. The focus is always in the inside. So I go 1, 2, 3, 4 this way. And that lands me with a focus of negative 6, 2. And since the focus is always on the inside of the parabola, it's got a curve to the left, which means its basic type is y squared equals negative 4px if the vertex were the origin. We're translated to negative 2, 2, so y gets replaced by y minus 2, x gets replaced by x plus 2, the p is 4 because it's 1, 2, 3, 4 to either the directrix or the focus, 1, 2, 3, 4. So y minus 2 squared, that's a 2, equals negative 4p x plus 2. Final answer, y minus 2 squared equals negative 16 x plus 2. Okay, so I want to clean up some parabolas from there. And now I'll get started with doing some ellipses. Basic ideas for ellipses. Put these on your cheat sheet, page 329. X squared over a squared plus y squared over b squared equals 1. Or x squared over b squared plus y squared over a squared equals 1. Okay. The ellipse is going to bulge either horizontally or vertically. Okay. It depends on which number is bigger. The number underneath the x and underneath the y, if this one's bigger, it's bulging in the x direction. If this one is bigger, it's bulging in the y direction, as we shall see. Okay. Okay, so number 1, 6.3. So what was the assignment again? Number 33 odd. Note again, 6.2, skip 33 and 35. That means we're stopping at 31. 6.3 is 1 to 33 odd. I'm not sure if I showed it to you. Page 334. Here we go. More. Whoops. Hmm. 33. And there we go. Okay. Number 1, x squared over 4, it just says y squared, treat it as y squared over 1. That tells me a is 2, take the square root of that. B is 1, square root of that. So the number underneath the x is bigger, so I'm going more left and right than up and down. Okay, so starting from the center, which is 0, 0, unless it gets translated, I go 2 to the left and right, 1 up and down, draw my ellipse. Okay, here's vertex 1. The vertices is plural of vertex, 1 vertex, 2 vertices. the vertices are the endpoints of the major axis. So 2 to the left, 2 to the right, negative 2, 0, 2, 0. Up and down is 1 unit, 0, 1, 0, negative 1, the endpoints of the minor axis, and there's no special name for them, just endpoints of the minor axis. Okay, for the ellipse, a squared equals b squared plus c squared. Put this on your formula sheet. A squared is 4, b squared is 1. Simple algebra, c squared is 3. C is radical 3, which is about 1.7. So 1.7, 1.7. Now again, I need the 1.7 just to tell me where to put the dot, but you should always give exact answers in your final answer. So for focus 1, I don't want you to write negative 1.7. I want you to write negative radical 3, comma 0. And focus 2 is positive radical 3, comma 0. So here are the two foci, one focus, two foci, F-O-C-I, plural focus. Okay. And yes, reflective properties of an ellipse. If you have a beam of light or sound or whatever, if you're in this ellipse, if you bounce any ray off of the ellipse, it'll go through the other focus. So bounce like that and like that, or bounce down here and come over there, or bounce like that and come over here. If I just go straight over here, it'll of course bounce back over there and so on. Okay. Number 3, it just says x squared. Treat it as x squared over 1 plus y squared over 9 equals 1. Okay, our definition of A is the larger number. So you take the square root of each of these. Square root of 1 is 1, that's B. Square root of 9 is 3, that's A. Okay. So you don't necessarily go by A and B being the number underneath the X and the Y. We're using the convention that whichever is the larger number. Okay, the square root of 9 is 3, that's bigger than this. So A is 3, B is 1. So left and right, I go 1 unit, negative 1, 0, 1, 0. Up and down, I go 3 units, 1, 2, 3, 1, 2, 3. These are the vertices. So 0, 3, and 0, negative 3 are my two vertices. Okay, so this ellipse was bulging left and right. That's because this number is bigger than this number. This ellipse is bulging up and down because this number is bigger than this number. How about if these two were equal? Have a circle. Okay, because you're going the same amount left, right, up, and down. Here, the amount you're going left and right is different than the amount up and down. Okay, find the two foci. A squared equals b squared plus c squared. A squared is 9, b squared is 1. Subtract 8 is c squared. So c squared is 8, c is radical 8, or 2 radical 2. Okay, that's about 2.8. The foci are always along the major axis. So I go up 1, 2.8, but write it as F1 as 0, 2 radical 2. And I go down 2.8, 1, 2. This is 3, right? So 2.8 is just off of it. So F2 is 0, negative 2 radical 2. And there we go. Okay, 7 starts off like this. Okay, the right-hand side isn't supposed to be 6. It's supposed to be 1. Make it a 1. Divide by 6. There's a 1. That becomes x squared over 2, y squared over 3. This is bigger than this, so it's going to be bulging vertically, although in this case, they're pretty close. It's hard to tell. Okay, take the square root of each of these. Well, square root of 2, that's B. Square root of 3, that's A. That's about 1.7. That's about 1.4. Punch it in the calculator. So this is kind of awkward. I go up 1.7 and down 1.7. So my two vertices are vertex 1, 0, radical 3, and vertex 2, 0, negative radical 3. Left and right, I go radical 2, which is about 1.4. So 1.4 left, 1.4 right. I use a decimal approximation just to tell me where to put the dot, but you present your answer as exact, meaning leave square roots as square roots. Okay, so negative radical 2, 0, and positive radical 2 comma 0. And what are these called? They're not called anything. They're just the endpoints of the minor axis. Okay, so exact answer means leave pi as pi, leave e as e, leave ln as ln, leave square roots as square roots. Okay, only punch it in your calculator if you have a decimal approximation. In mathematics, we like to keep things exact. Once you punch it in your calculator, it becomes inexact, right? Okay, these two are not nice, but the C is actually nice. If I plug in a squared equals b squared plus c squared, so a squared is 3, b squared is 2. If I subtract, I get 1. So c squared is 1. That means c is 1. That's nice. So I just go 1 unit up, 1 unit down. How do I know it's up and down? Because the foci are always along the major axis. So F1, focus 1 is 0, 1. Focus 2 is 0, negative 1. And that pretty much clinches it. Okay. Now, starting with 9, we have to complete the square again. So there's a completing the square mess. 11, x squared plus 4y squared minus 2x minus 16y plus 13 equals 0. So do you recall completing the square, the half and square concept? The first thing I do is move the 13 over. It becomes negative. Put the x's together, put the y's together. So x squared minus 2x, ignore the red. 4y squared minus 16y, ignore the green. And furthermore, factor out the 4. So 4 parentheses y squared minus 4y. Okay. So let me show you how I'm rewriting the original right now. X squared minus 2x, there it is. 4 times parentheses y squared minus 4y. That's 4y squared minus 16y. And the positive 13 on the left became a negative 13 on the right. All right, now I do the completing the square. Half and square. Half the coefficient of x, half of negative 2 is negative 1. Square it, you get 1. So in red, plus 1, both sides. Do the same thing for y. Half the coefficient of y and square it. Half of negative 4 is negative 2. Negative 2 squared is 4. So plus 4. But in green, where I write the plus 4, that's really plus 16 because it's being distributed by 4 times 4. So it's a plus 16. Right? So the right-hand side becomes, let's see, negative 13 plus 1 plus 16, that's 4. That factors into x minus 1 squared. That factors into 4 parentheses y minus 2 squared. Okay, and the right-hand side is 4. Just like the previous problem, it's supposed to be 1. Divide by 4. X minus 1 squared over 4. 4's cancel out. Y minus 2 squared over 1 equals 1. Okay, so this is a translated ellipse. My new center is 1, 2, right? X gets replaced by x minus 1. Y gets replaced by y minus 2. Center is 1, 2. Square root of this, 2. Square root of this is 1. This is the bigger number. So A is 2, B is 1. That tells me it's bulging horizontally because this is a larger number. So my center is 1, 2, 1, 2. A is 2, 2 to the left, 2 to the right. So here's vertex 1, negative 1, 2. Vertex 2, 3, 2. Up and down, 1 unit. So 1, 2, go up 1 unit is 1, 3. Go down 1 unit is 1, negative 1. Foci. Well, we've already played this game before. A squared is 4. B squared is 1. Subtract, you get 3. So C is the square root of 3. The algebra is exactly the same as this, right? So C is about 1.7. So from the center, I go 1.7 to the left, 1.7 to the right, but I write it as focus 1, 1 minus radical 3 comma 2. I was here, I just subtract radical 3. So the only way I can say it is 1 minus radical 3, comma 2. And F2, focus 2, 1 plus radical 3, comma 2. And there it is. That's what my ellipse looks like. Okay. So that's what's happening with these ellipses, it looks like. Okay. So how much more do I want to do? What time is it? A little bit past 9:30. Number 9. So same thing, complete the square. So move the 12 over. This time y squared doesn't have any y associated with it, so I don't have to complete the square on the y's. I do with the x's. See how there's a 4x squared and 16x? Now, if they give me y squared and I don't know, minus 8y, right? Then I do the same thing as the previous problem, but there is no y term, so there's no translation in the y direction, only in the x direction. So 4 parentheses, x squared plus 4x plus y squared, move the 12 over, minus 12. And then complete the square. Half of 4, 2. 2 squared, 4. So in red, plus 4. But that plus 4 again is really plus 16. 4 times 4 is 16. This factors into 4 times x plus 2 squared plus y squared equals 4. Again, the right-hand side is supposed to be 1, so just divide everything by 4. So we're seeing a lot of recurring themes here. So that's x plus 2 squared over 1 plus y squared over 4 equals 1. Okay, so where's my center? Read it right off here. Center is negative 2, 0. B is 1, A is 2. Square root, square root. It's bulging this way, vertically, because this number is bigger. It looks like the author likes to repeat their numbers. Okay, once again, I have C as radical 3. We've already seen this. It's our old friend by now. A is 2, B is 1. A squared equals B squared plus C squared. Put a 2 here. 2 squared is 4. Put a 1 here. 1 squared is 1. Subtract. C squared is 3. C is radical 3, about 1.7. Okay, so here's the breakdown of this. So here's negative 2, 0. I go 1 to the left and right, negative 3, 0, negative 1, 0. Those are the endpoints of the minor axis. Major axis, A is 2. So I go up 2, I go down 2. So vertex 1, negative 2, 2. Vertex 2 is negative 2, negative 2. Okay, then the C was radical 3. So I go up 1.7, go down 1.7, but you write it as F1, negative 2, comma, radical 3. So don't write it as 1.7, write it as radical 3. That's exact. And I go down radical 3. So focus 2, negative 2, comma, negative radical 3. And there we go. Okay, then how do you use something like 19? Find an equation of the ellipse that satisfies the condition. Okay, foci are 0 plus or minus 1. X-intercepts plus or minus 2, 0. Foci 0 plus or minus 1. And we go through plus or minus 2, 0. Those are the endpoints of the minor axis. B is 2. How do I know that? The foci are along the major axis. That tells me C is 1. Okay. So it must be bulging vertically. Foci are 0 plus or minus 1, centered at the origin, because it's halfway between the two foci. So I use my A squared equals B squared plus C squared. A squared is 4 squared, 2 squared is 4, plus 1 squared is 1, 5. So A is radical 5, 2.2. So I go 2.2 up, 2.2 down. The equation becomes x squared over 4 x squared over b squared, plus y squared over a squared, y squared over 5 equals 1. And that's that. Okay, and I'm just about done, folks. I want to go back and do one other parabola that I was asked about, 6.217, and then I'll stop after that. So I'll be done in a couple minutes, folks, unless anybody has a question. 6.217, page 325. 3x squared minus 12y plus 4y plus 8 equals 0. Go back and tackle that one. Okay, so first move over the 4y and the 8. So negative 4y minus 8. Factor out the 3. 3 parentheses x squared minus 4x. And then I complete the square. Half of negative 4 is negative 2. Negative 2 squared is 4. So add 4, but that's really a plus 12, we said before, right? 3 times 4 is 12. So to balance it, I add 12. This factors into 3 times x minus 2 squared. This becomes negative 4y plus 4. Factor out negative 4 parentheses y minus 1. Divide both sides by 3. So x minus 2 squared equals negative 4/3 y minus 1. Okay, so the vertex is 2, negative 1. Squared in x, not in y, and a negative means it opens down. Okay, make this look like negative 4p something. So negative 4/3 equals negative 4 times p. And multiply both sides by negative 1/4. Cancel, cancel. So p is 1/3. Okay, so since p is 1/3, the vertex I already know is 2, 1. I go 1/3 of a unit up, y equals 4/3 of the directrix, and I go 1/3 of a unit down. So that focuses 2, 2/3. I guess this is a little bit too high, but that's just 1/3. Okay, so that's that one. Okay, so I'm finished with that. I do have some questions from the chat. Let me check it, see if I'm willing to do it. Okay, 21. Let me see. 21. I'm assuming you mean 6.3. Okay, foci on the x-axis. Okay, yeah, I think I'll hold off on 21 until tomorrow. So if I don't do it tomorrow, please ask tomorrow. Okay, so I think we're okay time-wise, but we'll see how it goes. Did I change the assignment also on this? Yeah, originally I was going to do that. Yeah, so the new assignment is only 1 through 27, please. Some of the other ones got to be too weird. So 1 to 27 odd. Sorry. Let's make this 1 to 27 odd. 6.3, 1 to 27 odd. Okay. All right, so I'm done with that. I'll do more ellipses tomorrow. And then Wednesday and Thursday, we'll go on to the hyperbola. And that'll lead us up to the next quiz. All right, so I'll stop the share. Let me check if there's any other questions in the chat, please. Let me see. Okay, I don't see anything else. Okay, any other questions, please? Otherwise, we're done for the day. All right, have a good day. We'll see you all next time. And that'll be it. Okay, bye, everybody.
Thank you.
Thank you.